Okay, in today's video, we're going to be talking about variable length subnets. So in the previous subnetting video, we talked about splitting a network into 2 equal parts, or 4 equal parts, or 8 equal parts, or 16 equal parts, or some multiple of the power of 2 equal parts. Today we're going to talk about what if all my network spaces aren't the same size? What if I want to break up my network a little bit differently? So we're going to stick with our regular address space of 192.168.140.0 in a /24 network, and we are going to break up this network space. Now we're going to assume that we have to create a network in which we have 62 hosts in our office. We're going to have 62 hosts in our sales. So our sales department's going to have 62 devices. We are having an exterior office. So in our exterior office, we're going to have 14 hosts. And then we're also going to have an IT department. So our IT department is only going to require 6 hosts. And then we're going to have, lastly, we're going to need to connect these network devices. So we're assuming we have a router set up something like this. Router 1 connects to router 2, connects to router 3. And so router 3 here is going to be out in our exterior office. So we're going to call it exterior R. We have an office R, and we have a sales R. So we've separated these a bit. So our sales department, all their hosts are off here. So all their host devices are going to be off there. The office is going to have all their host devices also off the office router. And then off the exterior office router is going to be both our exterior office, so our exterior office hosts, of which there is 14. We're also going to put our IT department out in that office. So we're going to say IT, and they're going to have 6. Okay, so obviously our network spaces are quite different. We have a few different networks here. We have this network space, which requires 62 hosts. We have this network space, which requires 62 hosts. We have this network space that requires 6 hosts. We have this network space that requires 14 hosts. And we actually have a couple of other ones in that we have this network between the 2 routers, which requires 2 hosts, and this network between those 2 routers, which also requires 2 hosts. So that's a total of 6 possible network spaces that we need, and we need to vary the different sizes of them. So we have the 192.168.140.0 space that we're going to go ahead and break up. So we have 6 possible address spaces that we need to account for. And what we do when we're designing a network address like this is we start with the largest network spaces and then we work down to the smallest. So if we had, for example, this network space that we were breaking up and we wanted to put half of it towards something, we would say, okay, subnet A is this bit. And then from there, we could break it up smaller. So if subnet B was half that space, we'd put B there. If subnet C was like half that space, we could put C there, and then D like so. So we can break up the network space like that, but we always start with the biggest chunk. So in this case, we have 2 large chunks, which is 62 hosts each. So we're going to start with those. We need to figure out how many bits we need in order to get 62 hosts. Okay, so we know that our biggest network space we're looking for is 62 hosts for the office and 62 hosts for the sales. So we're going to start off by splitting up our network into chunks that will allow for 62 hosts per chunk, and then from there we'll break up our further chunks. So if we're looking at 62 hosts, we know that the number of hosts is equal to 2 to the number of host bits minus 2. Those 2 are the network and the broadcast addresses. So the number of total addresses, or the number of hosts, so available addresses, is equal to the number, or 2 to the power of the number of host bits minus 2. So in this particular case, we're looking for 62 hosts, and we know that 2 to the power of 6 will give us 64. So this is 62 is 64 minus 2. In this particular case, it works out exactly. If we were looking for a network that, for example, only needed 50 hosts, we'd still have to use 6 host bits. We'd still have to use that 6 host bits that we have here. And the reason we still need 6 host bits is because if we go down to 5 host bits, we would get 2 to the power of 5 minus 2, which gives us 32 minus 2, which gives us 30 possible hosts. And if we only have 30 possible hosts, that wouldn't be enough. So what we need to realize is that anywhere between 31 and 62 is going to be require 6 host bits. So there's other ways that we can look up this data. For example, you can look up a subnet mask cheat sheet and look at that information. So I'll pull one up now. The top link that you're going to see is this alias.com. This is actually a pretty good cheat sheet, and you can have this open during the exams. So if you're looking, for example, at the number of hosts, we know we need 62 hosts. I would just look at the cheat sheet, say, okay, a 62 hosts is going to require 26 network bits, which you'll notice if we switch back to Drawboard and we're looking at a network address, we know that 192.168.140.0 is a /24 network. So if we write out this last one in binary, right? So if it's /24, it's going to break right on the dot. Okay, so it's a /24. And if we know that here we need 6 host bits, so as we set up here, we can say 1, 2, 3, 4, 5, 6 host bits. We're going to divide there. If we check that against the cheat sheet, what we'll notice is that 62 host bits is actually a /26 network. So when we look back here, what we see is that in fact, this 24 plus these 2 bits gives us a /26 network, which matches the cheat sheet as we saw in the other sheet. So we can either figure it out ourselves using this equation, or we should at least have some idea that this equation exists and works. But realistically, in terms of practicality, you're going to be switching to online, looking up the subnet mask cheat and just checking the number of hosts against that cheat sheet. Okay, so we know that we're going to need a /26 network, and that will allow us to break this network into 4 spaces. Look at a /24 network, and we're specifically going to look at how we can divide it up. So a /24 network is 2 to the power of number of host bits. And in this case, I'm not going to subtract the broadcast address and the network address because I just want to calculate all addresses, whether or not they're available to be used for hosts. So 2 to the power of 8 gives me 256. So if we had an address space that we wanted to split up, so we're looking at splitting up this big address space, we know there's 256 possible addresses, including networks and broadcasts. So if we divide that by 2, we're going to get 128 per. So we have 128 addresses here, including broadcast and networks, 128 addresses here, including broadcast and networks. If we were divided up further, so for example, if we were to divide this by 2, or to divide 256 by 4, because we've divided in half twice, what we're going to end up with is 64 possible addresses. So we're essentially taking quarters, and now we have 64 in each of these chunks. So we can already see that because we're looking for a 62 host address, what we're going to find is that our office is going to take up this first quarter. Our sales is going to take up this second quarter. Then our exterior office doesn't actually need all these 64 addresses, so we're probably going to want to have to split that one up again, right? We're going to need to split that address up. So maybe we have 32 and 32, and even then we don't need 30 available host addresses, we only need 14. So we might go further and say, okay, I want to split that up another time. So this time now I'm splitting up the 32. So now I'm going to have half of 32, which gives me 16 and 16. So now in here we have our exterior office. And then we could potentially, because we only need 6 addresses for IT, we could even split that last 16 up one more layer. So if we split this last 16 up, right, we're going to have a possible 8 addresses here, so 6 hosts, and a possible 8 address here, and this one we're going to assign to IT. So that's what we're going to do. We're first going to split the network up into 4s. We're going to take these first 2 subnets, and then we're going to break this this third quarter up into smaller chunks. How do we do that mathematically? Well, that's what we're going to do next using subnetting. So to get started, we are going to look at our address. So we're looking at 192.168.140.0, and we know it's a /24. Because we're going to be working only in the /24 section, I'm only going to convert the last section here into binary because I know we're going to be working only with that last octet. All of this, because this is all the network divide, all this side is going to stay exactly the same, so I'm not going to change it. Okay, I know that I'm going to use a /26 network because we already figured that out, so we're going to borrow 6 bits so we can split this into quarters. So what we're going to get is a network and a broadcast. So a network address has all of the host bits as 0, which we have here. We're going to have .00 with all ones. That's your broadcast address. So we know we have a network address of 192.168.140.0. And this is going to be a /26 network. We know we have a 192.168.140. This one's not going to be .0. It's going to be the binary address we have here with the 6 ones. So that's going to be .63, and that is also a /26 network. So this is our office subnet. We're going to go one more quarter, so 01 and 01, all host bits for the network, all ones for the host bits for the broadcast, and here we have 192.168.140.64, also /26. Remember that we can always just add one to the previous network's broadcast in order to get the next network's network address. So the broadcast here is going to be 192.168.140 and .127 /26. So again, we've split the network in half, and the first approximately 128 addresses have gone to these 2 quarters. Now, what we would normally do is we would continue to split this network, which we can absolutely do. So if we were to go through and split it, we could do 1010000000 for the host, 111111 for the broadcast, for the network and the broadcast. So we get 192.168.140.128. And we would get 192.168.140.143. Sorry, took me a second there to do the binary calculation. Okay, but what we know, sorry, this was our sales network. What we know from above is that in fact, we're not gonna split this into 4 quarters. So we could continue and split up the last quarter, we could continue and split up the last quarter here, which would be the network starting with 11, 11, and continue out there. But what we saw above is that in fact the office is the first subnet, the sales is the next subnet, and then we never used this last subnet here. We only used the third subnet and we split it up further. So what we're going to actually do is we're going to not use this last subnet, and we're not going to even use this third broadcast address because we're not going to look at, I'll just redraw those lines there. We're not going to look at this network address here as if it is a /26 network. We're not looking at it like a /26 like we did for the previous ones because this network doesn't need to hold 62 addresses. It's going to be our exterior office. So it's our exterior office network. So we're going to actually only need 14 hosts. So what we're going to do is we're going to pretend that we started with that. So we've already assigned those 2 addresses, no big deal. So now we're going to say, okay, we have 192.168.140.128, and this is a /26 network, and we're going to subnet it. So from this point on, we're just doing equal subnets, but you'll notice that we kind of didn't finish that subnetting and we're starting at the next network address. So now we're starting at this network address. We're breaking this quarter up into smaller pieces. or we need 14 network addresses. So we're going to look back at our subnet mask cheat sheet. If we're looking at 14 network addresses, we're looking at a /28 network. So I'm once again going to be splitting this network into quarters. So I'm going to write it out in binary. So 1, 0, 0, 0, 0, 0, 0, 0. The network split is at the current network split is at /26. So everything to the left of that is going to stay the same. And then the new network split is going to be at /28. So we're looking at a /28 network. So this portion is always going to stay the same all the way down. And then this middle portion is what's going to change. So in a /28 network, we first have our network address, which is 192.168.140.128/28. We then are going to have our broadcast address, so all the host bits become 1, which gives us 192.168.140. This time we're going to have 128 plus 15, which gives us 143 in a /28 network. And now at this point, our next network doesn't need to have 16 addresses. So although we can write out our next network address, 00, we need to increase this. So 01, all of our host bits are 1. We're going to have the next network is going to start at 192.168.140.144. Again, I could have just added 1 from the previous network's broadcast. But what we're seeing here is we're no longer going to want to work with /28. So this is our exterior office, which required 14 hosts. So we've now accounted for 3 of our network spaces, and we're going to need to, from there, calculate down our 4th network space. So this one is going to be smaller than a /28 because we don't need to have 14 possible hosts. We need to have 6 possible hosts. We look at our subnet mask cheat sheet. We 6 possible hosts is a /29 network. So what we're actually going to do is we're just going to split this last network address space we're looking at into half. Okay, so now we're essentially starting back with this same address here. So this address comes down. We're essentially starting with 192.168.140.144 as a /28 network. And we're just going to pretend that's the address we were given in the beginning, and we need to split it into 2. So we're going to start off by converting it to binary. 10010000. That's the network address in /28. So the /28 splits it right there. We know that we're going to need to split this network in 2, so we're going to need to borrow 1 bit, and we're going to calculate out these addresses. So this is 192.168.140.144/29. We're going to try the subnet mask, so everything to the left, so all the network bits stay exactly the same, but all the host bits become 1, which gives us 192.168.140.151. Also a /29 network. And then that's the only address we need here, because this is our IT network. And it only needs 6 hosts. So we have our 6 hosts accounted for here. Now what we need to do is we're going to continue working. So if we were to look at the next network address, the next network address would be if this was a 1. So 001.000, which gives us 192.168.140.152. Also, this is a /29, but we're not going to worry about that right now. To get to the network, you could have just added 1 to the subnet mask from the previous network. And we need to split this up further. So to take you back to our diagram, we've already calculated this address, our nice sales network. We've calculated our office. We've calculated our exterior office and our IT. So all we need is these little 2 network chunks. So we're going to go all the way down. And we're going to, once again, start with our remaining host address, 192.168.140.152. This is a /29 network. And we are going to split it into networks that allow for 2 hosts. So a network that allows for 2 hosts, looking at the subnet mask, is going to be a /30 network. So it has a subnet mask of 255.255.255.252. So what we're going to do is we're going to go ahead and split this into a /30 network. So once again, I'm going to write this out in binary, so it's a little bit easier for us to work with. We know that we started with a /29 network, and we're moving to a /30 network. That gives us a network address of 192.168.140.152/30 to a broadcast address where all the network bits stay the same. This network bit stays the same. The host bits all become 1, which gives us 192.168.140.155/30. We're going to do our next network address, so all the previous network bits stay the same. The new network bit changes. All the previous networks bits stay the same. And we have, for this network, 2 host bits of 0, and for the broadcast, host bits are all 1, which gives us 192.168.140.156/30. Once again, to get the network, you can use +1 to the previous network's the previous network's broadcast. And then we'll calculate the broadcast by converting here 192.168.159/30. Okay, so this is going to be the connection between, say, sales and the office router. I don't remember what I called them. And this is going to be the connection between office and exterior office router. So now we've accounted for those 2 networks. So to just go through and give you an idea of our network space so that you have an idea, I'm going to redraw the diagram and write in all the network addresses that we have. So we started with a sales router, okay, and it's connected to an office router, and it's connected to an exterior office router. And in the exterior office, we have our IT department, which will have various hosts, and we have our exterior office staff. Off the office router, we have our main office staff. And off the sales, we have our main sales staff. Now, the network addresses that we calculated here for starting with the office staff, because that was the first network we did, would be 192.168.140.0 in a /26 network. The sales network was the next one we calculated. This would be 192.168.140.64 in a /26 network. The exterior office was the next one we calculated that needed 14 hosts. So this one was 192.168.140.128. This was a /28 network. The IT was one of the last of the big networks that we calculated. It was 192.168.140.144 in a /29 network. Okay, and then we calculated the networks that were in between the routers. So in here, we ended up with 192.168.140.152 in a /30 and 192.168.140.156 again in a /30 network. Now we could have switched those 2 addresses around. It doesn't really matter which we assign where, but just so you're aware, these are the networks we do. Now, traditionally speaking, if we were to assign addresses from this space to various interfaces, we would assign the default gateway. So let's say this is G00. we would assign that to be 192.168.140.65 because we want the first available address space in that network. And because it's a /26 network, we're going to need the subnet mask that aligns with /26, which is 255.255.255.192. For subnet masks, you can also look at that cheat sheet. Has all the subnet masks right on it, so that's pretty useful. Okay, if we were assigning a default gateway to this network, we might assign, let's say this is S000, we might assign the first address available, so 192.168.140.153 in a /30 network, which is going to be a 255.255.255.252. I'm not going to fill in all the subnet masks here because I will run out of room. Okay, and if we were assigning here on this router to S000, this is a different S000 because it's on the office router, we might assign it the next available address, which is 192.168.140.154, and this network address is also going to be a /30 network. If we were assigning these hosts, we would just follow a similar strategy. So if we're looking at this router interface, we're looking at one more. The default gateway is one more than the network address, so 192.168.140.1/26. This one is going to be, these ones could be either or because they're both sort of default gateways. So 192.168.140.157/30 and 192.168.140.158/30. And then down here, we're looking at exterior office. I'm going to have to get a little creative with my spacing here. So let's say this one would be 192.168.140.129/28. And this one, very last one, the IT default gateway would be 192.168.140.144/29. If a packet tracer says that you need to assign a PC the last available host address, so the last available host address, last available host is one less than subnet mask. Sorry, not subnet mask, then broadcast. The reason they're saying that is because in order for the packet tracer marking to mark it correctly, it needs to have exactly the correct address. So you need to make sure that if they say assign the PC the last available host, you're actually assigning it the last available host and not just a host available in that network space. Because although technically if you were building a network, you could do that, packet tracer won't be able to mark it correct unless it has the matching address. So if it doesn't have the matching address, you're gonna have issues. So just make sure you're paying attention to any notes they make, like assign the default gateway the first available address, assign the last available address to the host, assign the first network to office, etc. But yeah, that's pretty much how we do variable length subnetting. It's all about breaking it up into chunks and then breaking those chunks into smaller chunks using things that we know how to do. So hopefully from there, you're able to do variable length subnetting. I do recommend that you organize your subnetting, your variable length subnets in a spreadsheet of sorts, and then create a network addressing table. Right after this video, I will create a short video showing you how I would do the network addressing in a spreadsheet. So now that you understand the math, how I would do this exact same network, but in a spreadsheet, and you'll see that it's a little bit smoother than what we have here. Okay, so good luck with your variable length subnets.